Okay, and then we'll get started with the lecture. So as always, just a really quick review to get us started. Last week we looked at assumptions and how to reconstruct implicit assumptions in arguments. Just to remind you that we were using the concept of assumption in a special technical sense. So we weren't just using it in the everyday sense of anything that you might assume without further argument, but in the specific sense in which an assumption that you need to fill in for an argument will be one that is required in order to make the conclusion follow from the premises. So an assumption that is not explicitly taken, that is not explicitly stated, but that is really needed, for instance, to link up with another premise to move on to the conclusion. So that was the sense that we were looking at in here. And if you, in an assignment, need to reconstruct implicit assumptions, we will let you know. The slightly other example that we had looked at in tutorials was assuming a claim for the sake of argument, for instance, in a reductio. That's a slightly different sense, right? That would be one where you have an explicit premise, but it's just fulfilling a certain function. So for our purposes, this is what we need. We then looked at 3 different rules for identifying assumptions. First of all, if you see a single premise, that is a good indication that there might be something missing. That doesn't work in all cases, but when there is a single premise, it's very likely that there is an implicit assumption being made that needs reconstruction. That said, if there are several premises, there might still be further implicit assumptions. So that's really just a first shortcut indication. And then there were kind of 2 mirror rules that looked either at the conclusions or at the premises that are actually there that can be used to also, again, identify whether a further assumption is needed and or what that assumption is going to have to be. So the first one was going to be if there is some relevant concept that suddenly appears out of nowhere in the conclusion, then that is an indication that there is an implicit premise being made that needs to be made explicit, and it's going to have to mention that key concept that suddenly appeared out of nowhere in the conclusion. And the last rule was exactly the mirror image of that. If there is some key concept, important term, or phrase that is in one of the premises but doesn't turn up in any of the other premises, then again that is an indication that something is missing. So other premises will have to link up to those important relevant phrases, concepts, terms, whatever. So if you use those 3 rules, that will help you, for our purposes, reconstruct any implicit premises that you need to. And the rules for doing that for more complex arguments are going to be exactly the same. So basically there the idea is just, again, to break those more complex arguments down into smaller units that then can be treated as just good old-fashioned simple arguments. So the first example being arguments with convergent premises, with independent premises. These we would treat as a number of different arguments with a single premise that just happen to support the same conclusion. So in all of those cases, each of those single independent premises will typically be linked to an implicit assumption that you can make explicit. So again, if you have identified an argument that relies on several such independent premises, that's again also an indication that you need to reconstruct assumptions, right, if you're asked to do so. And then the same thing is going to happen at the lower level for sub-arguments as well. If a sub-conclusion depends on a single premise, then that again is going to be something for that you need an additional assumption. So that was kind of the squashed version of what we did last time. Anything unclear about that? Okay. So then we'll go into today's topic, which is generalizing from a sample. And there are going to be a lot of concrete examples of this. And I think you'll find that this is something that is really central both for science and kind of, as is so often the case for these issues, for everyday reasoning as well. If you read the study guide, how many people read the study guide? Oh dear. We're getting to that point in the semester. Well, then that's So this is one of the most famous examples of an example of arguing from a sample that went really, really wrong. So the Literary Digest poll, squashed version, it looked really good to begin with. So this was an extremely well-renowned, high-reputation magazine, the Literary Digest, adding extremely good track record in predicting the outcome of presidential elections as well. And this was also one of the largest and most expensive polls ever done. And as you can see here, they were completely wrong in their prediction, right? So they predicted exactly the opposite of what would happen. And actually, if you look at the percentages, it wasn't that they were just a little bit off. They were quite significantly off. And the surprising thing was that another poll, the Gallup poll, with a much smaller sample, correctly predicted the actual outcome, namely that Roosevelt and not Landon would win. So what was going on here was a biased sample, right? So size alone does not matter, and that's kind of the message. You can ask as many people as you want if you're selecting them based on the wrong criteria, and what those criteria might be itself can be a matter of discovery, right? Just realizing that can actually be progress to improve future polls. If you use the wrong criteria, that can totally bias your results. So in this case, they were using lists of car and phone owners, and those were likely to be kind of more rich Americans who are also more likely to go Republican. So that biased the result. So that's the one famous example. It doesn't get better because here's another almost equally famous example that kind of upped the ante just a little bit. So here we have the Chicago Tribune, classically a quite, well, they were kind of a Republican-leaning, quite anti-Truman newspaper. And here they're reporting on election night that Dewey won the election. And there you see President Truman, who had just been reelected, in fact, holding exactly that, that newspaper and being quite happy and amused about it, right? So what had happened here, the Chicago Tribune went to press before the results were actually in. They relied on polls, on 3 different polls. And these 3 different polls, again, had many of the same problems that we'd seen a few years earlier in the Literary Digest poll. Again, based quite strongly on, telephone interviews, so the same problems with socioeconomic status and political leanings there in the background. And that even though they had been quite careful to select demographic groups that would be representative, right? So how many percents of, how large was the percentage of Hispanic voters, of Caucasians, and so on and so forth. But it's just that the people within those groups that they were selected were still likely to be biased and highly selected, and they also stopped polling too soon. So they basically lost all of the undecided voters who largely voted for Truman. So this was making it worse because this was actually having biased polls plus pretending that these were factual results. So this is an important area, and one would think one would learn from mistakes as well. So here's the definition of inductive arguments, and you will notice that this is a little bit different from what we've been saying so far about the contrast between inductive and deductive arguments, and I'll come back to that in a minute. But for now, in this context, we're going to use inductive arguments as arguments that make an inference from a sample, so a subgroup, a smaller set of instances, to a larger group, a whole population of instances, right? Or maybe even from one to a more. So moving from a particular claim, a claim about the particular, to a general claim. That's going to be the general definition, and you can see that there are a couple of key terms in there. So this is something that we'll be looking at in tutorials, because if we have that kind of argument, then the key problem will become how to exactly figure out, and that's sometimes very obvious and sometimes not so obvious, what exactly the sample is, what the population is that is being talked about here, and what the target property is. So target property is going to be the thing that is supposed to be measured, right? The thing that you want to know, for instance, voting behavior, right? Likely decision in a presidential election, something like that for the two examples that we just saw. The population is the large group of people or objects or things or whatever processes that you really want to know something about. So, right, in an election, that would be all American voters or something like that. And the sample is going to be, in that case, the number of people actually interviewed, right, who actually responded to the poll. And only if you know those three things and then a bit more in the background can you actually evaluate that type of an argument. So here are a few examples of how that is done, and that might make it a bit more clear. So say we have a Gallup poll investigating Americans' approval of the president's overall job performance, finds it's only at 33%, and it's based on telephone interviews, which hopefully in 2006 is no longer that much of a problem. Maybe today landlines would be the problem or something like that, with 1,000 people. So then we would have a sample of 1,000 adults actually interviewed, right? It would be possibly important to draw a distinction, but we'll get back to that later, between people called and people actually interviewed, right? We all know how we respond to telephone queries, and we're saying, sorry, I don't have the time right now. So these would be the people who actually answered the questions. The population is going to be all adult Americans, all adult American voters, and the target property, the approval ratings, or their actual approval. So that should be quite clear, right? Anything not? So it's not. So one thing to see here, and hopefully that's also quite obvious, is that we're not always going to be talking about people, right? So population in this sense is not always going to refer to groups of humans. We can also have something like this, right? A sample of a number of experiments actually conducted, say with carbon-14. That's supposed to say something about, well, how that particular carbon behaves in general, so all instances of that, and the target property here would be its half-life. Yeah, so that can also be something that can be terminology that is used for all kinds of scientific investigations as well. And finally, you can have cases like this that are just kind of informal, masked inductive arguments or quasi-inductive arguments. They're not really depicted as such. And we just have a simple claim saying I like or I don't like X. So from that, you know, why is that? Every time I've experienced X, it's been really awful, so that must be true for all instances of X or something like that, right? So that's not to say that's a good argument, but we could still reconstruct it in that same way by identifying sample, population, and target property. And we can also see that this is kind of an example where the distinction between what actually is the sample and what actually is the population is not so explicit. So there it sometimes takes a little bit of interpretation to see what's going on there. Yeah. So let's have a bit of a longer case. And if you could read through this, or actually I'll read it out, and maybe then you can take a minute or two and discuss with your nearest neighbor what the sample is going to be here, what the population is going to be, and what the target property is. And then we'll just move through those and see whether that worked. So we have a 1989 study that reports that 65% of students in Ontario universities are moderate drinkers. The Addiction Research Foundation undertook the study. From 4 unidentified Ontario universities, 13,200 full-time undergraduates were randomly selected. Questionnaires were distributed by email. 5,000 students responded. So just take a minute or two, discuss with your nearest neighbor, sample, population, and target property, and then we'll bring that together. So what are people thinking about the sample, first of all? I think I'm hearing some good answers here. So who wants to take that one? So the 5,000 full-time undergraduates, why wouldn't it be this group? So those aren't the answers that came in there, right? So that's an important distinction to make. And that is also an important distinction to make because if you had a case like this that just said so and so many undergraduates were selected and the results were such and such, right, then you'd need to know what the actual response rate was, right? So it was exactly those 5,000. Yeah, is that clear? So the people that actually responded. Target property. What is being investigated here, or most likely being investigated? How much they drink, how many students there are, being an undergraduate student, being a student in Ontario. What's the target property? A. So actual alcohol consumption, how much they're actually drinking, good. And population is going to be what? Of those, so all students of those 4 universities, all students in Ontario, all students in the world. What is it going to be? D? Yeah? So all university students in Ontario. And that's a tricky one, right? Because that kind of is going to depend on the intent of the study a little bit as well. So what it's supposed to show, and that's what you get from that first sentence, right, is drinking behavior in Ontario students. So that's our population. And then the prize question, of course, is whether our sample is actually representative of that population. Good to go from here? So then we come back to the question of inductive arguments and how we're actually using that term, right? So inductive arguments are always going to be generalizing from a sample to a larger group, a larger population. And that's always also going to depend, among other things, and there are more, on how representative that sample actually is. Now, how does that relate to the contrast between inductive and deductive that we were using earlier in the semester? So that's the next question, and here's just a bit of clarification on that one. So if you remember, we had said that an argument is going to be inductively valid if it provides good reasons for accepting that the conclusions are likely true. And we contrasted this with a deductive argument in which true conclusions are guaranteed, true premises are guaranteed to lead to a true conclusion, right? So the difference was going to be inductive validity was going to refer to arguments that very likely lead to true conclusions versus deductive ones are guaranteed to lead to true conclusions. There's no other possible outcome. Yeah? So these are obviously two slightly different senses of inductive. So how do they relate to each other? How can we draw that difference? Well, first of all, we can visualize it like this, again, in terms of the types of diagrams that we've been using earlier when we talked about generalizations. If you have this type of an argument, generalizing from the particular to the general or from a sample to a population, can that ever be deductively valid in the sense that true conclusions are guaranteed to follow from true premises? So can these types of arguments ever be deductively valid in the more general sense that we were talking about earlier in the semester? Does anybody have a thought about that? So it seems that those can't ever be deductively valid, right? Because that's always, here you're always dealing with probabilities. How likely is it that the larger group that is actually going to behave in the same way, have the same target property as the smaller group? How likely is it that the smaller group is actually representative of the larger group? What about this type of case? Deduction, here we're moving in some sense from the general to the particular. Is that always going to be deductively valid? Is that always going to be a case where the conclusion is guaranteed to be true if the premises are true? So that's no one? So for those types of arguments, inference from the general to the particular, here it seems that you could have both types of things. Here it seems to be the special case where you could have either cases of inductive or deductive validity, right? In some cases, and I'll give you an example in a second, the conclusion will be guaranteed to be true, and some it will be probably true. So inductive arguments, that's the take-home message. Inference from a population, from a sample to a population are always going to be inductively valid. Examples of inference from the general to the particular can be either inductively or deductively valid. Yeah. So let's look at, first of all, this example. So here we have three arguments about Martians. And then the first question is going to be, which of these is not an example of an inference from a sample to a population? So is not an instance of an inductive argument in the narrow sense that we're using today. Is it A, B, or C? So this is just about the direction of the inference. Right? Look at those. No one? C, right? So that's a deductive argument in the sense that it's moving from a population to an individual, namely to a particular Martian. So that's just focusing on the direction of the inference in which it is drawn. Yeah? Okay. And now you have two more. So these are both deductive in the sense that they're both moving from a group to a subgroup or to an individual, right? All Martians have green skin. Therefore, the Martians in this spaceship also have green skin versus most Martians have green skin. So this particular one also has green skin, right? So they're both deductive in that sense. Which of them is also going to be deductively valid? So in which case is the premise, is the conclusion guaranteed to be true if the premises are also true? A, right? So if it is a universal truth, as we all know, that all Martians are green-skinned, then the Martians in this spaceship could not have any other skin color. That is completely excluded, right? B, we're just talking about most of them. So there might be a strong or a less strong likelihood that this particular Martian has green skin, but it's not completely guaranteed to be true. So that's right? Why deductive arguments can be both inductively and deductively valid. Yeah? So that's just something to keep in mind in the background. You don't have to make this distinction that I just explained in the assignments, but it's kind of useful to know just to keep those terms apart and to sort them out a little bit. Sample sizes. How big is big enough? Now, I think there are clearly cases where we can all say, just almost intuitively, right? Sample size of 1, like in these cases, just anecdotal evidence, that just isn't good enough, right? So those are just kind of obviously cases where we don't have a large enough sample. But there could be other cases. And to kind of make progress on that one, here's a bit of an example. So let's take a town, has 2 hospitals of different sizes. The large one has 45 baby births per day, and the smaller one has 15 babies born each day. And roughly 50% of those babies are going to be girls, generally speaking. So the exact percentage of girls is going to be different for every day. Slight variations occur, sometimes more, sometimes less. And then for 1 year, each of those hospitals is going to record days on which more than 60% of the babies were girls, so in which we have an atypical example, right? And what would you predict? Larger clinic will have more such days, or will the smaller clinic have more such days over a year of an atypical result? Or does it just not matter, right? Because we're looking at a whole year and maybe they're just going to come out roughly the same. How many people think it's A? Just show of hands. How many people think it's B? How many people think it's C? Okay, so a lot of people are undecided, but roughly equal amounts of people think either the smaller clinic has more such days or it doesn't matter, it's going to be equal for both cases. So the right answer is actually this one. Does anybody know what the thing going on in the background is?
Because there are less babies born each day, you need less to be born as a girl, less disparity to throw off the statistics.
So if you have a smaller sample size, you're going to be more likely to have non-average atypical results, right? That is, the smaller group you probe, the more likely it is that you get kind of weird coincidental results that aren't truly representative of the more general percentage of roughly 50-50. And we'll go, yeah?
Just as likely that it could skew the other direction, let's say it's like minus 30.
But that's not the question, it's just asking if there's going to be more.
Right. So they would, okay, so that's a potential misunderstanding, right? Isn't it equally likely that they might have 40% more days with 40% of births? Was that the question? So any atypical result is going to be more likely if you have a smaller sample. So don't be confused about the more or the 60%. The point is that the deviation from the normal, the average, is going to be more likely for the smaller sample. You can do this at home. So I'm not going to talk through this one in great detail, but you can actually run this experiment. So you have a deck of cards, you deal out 4, you've shuffled it well beforehand, and then think about the likelihood of them all being read again and again and again. Is that more likely than the case where you deal out 8 cards and again get 8 that are all read, right? And this is basically the same example, where again we would expect the atypical result to be more likely for this one. And you can actually, so here's kind of the maths behind it that I'm not going to explain, but you can actually test that out at home. And then it kind of makes maybe more intuitive sense if you're using a smaller number of cards that you would be more likely to just hit on the 4 red ones. Yeah? So that's the principle, the general principle behind the 2 examples that we were just discussing. Larger samples are more representative. The smaller a sample is, the more likely you are to get actually weird, unrepresentative, atypical results. And this is true for random samples mostly, right? And in real life, most samples are not actually random. So then it gets a bit more difficult. So maybe just 2 words on what you do in that case. Well, one thing is, so often in these cases, background knowledge is going to be needed to determine the actual size of the sample that is needed. That's going to be different in different cases. What kind of background knowledge? Well, it's going to depend on how much expected variation you expect based on previous experience, on previous studies, you think is going to be going on in the background there, right? For something like chemical elements, you wouldn't expect so much variation, right? So there, if you really think that they're going to be alike in the relevant target property that you're investigating, then maybe a very small sample is going to be good enough. There could be intermediate cases. A case where you would probably need or expect a lot of variation would be psychology studies, right? What kinds of stereotypes do people have? What kind of political leanings, and so on and so forth. So there you would need much larger sample sizes, and there things would be a lot trickier. And some examples of those in a minute. So it's kind of important, is the message here, when you're evaluating that type of an argument, to really take into account what type of a sample you're evaluating, what type of a target property, and why or why wouldn't you expect variation in that one. Yeah? So no general answer, but maybe a way of thinking about it. So let's think about some ways in which samples can be biased. And here's going to be one that is representative of a lot of cases that you might have in general, right? Completely non-scientific, something we do all the time. We look at ratings. We look at restaurant ratings. What's the best coffee on campus? What's the best series in the International Movie Database? And so on and so forth, right? And based on that, what should you watch? And then you look at the user comments and try to decide. So one thing you might see there, okay, fairly large group of shows that were rated. Breaking Bad, that seems to, be substantiated by what people say about it, comes out on top, right in front of Game of Thrones. Sample size, well, almost 2,000 votes. That's not too bad. So that would be one way of going at it. Then you look at another list on the same page. Now we have a smaller number of shows, right? We have similar results. So Game of Thrones and Breaking Bad are still in the top 3. We have many more votes, but the order is flipped. So what is a general thing to consider with this type of a rating, right? I mean, one issue is going to be, does that reflect, quality or individual preference and all of that stuff? That's going to be one consideration there in the background. But what would a general question be about any such type of examples where people are asked to vote on something, on a web page, in a newspaper? Anybody have something? Or maybe I'll give you a slightly different example, which just really has different content, but is actually the same in the problem that it has. So something like this, news report. You all heard about the thing in New Zealand with the flag. So does Australia need a new flag? And then here there's a reader poll. How do you think, yes or no? And a vote, and we have roughly 3,000 votes. So should we conclude that Australians think that a new flag is needed, let alone this one? Should we conclude that all humans think either Breaking Bad or Game of Thrones is the best, just the best series at all, and those types of ratings? So what's the key question here to ask, or the key bias here in the background? Yeah.
Like older people who can be more conservative about change of flags, why usually use the internet to check these things?
Mm-hmm.
Or like look at the age for that kind of stuff.
Yeah.
So they might be almost entirely excluded. It might be more like teenagers and young adults
Mm-hmm.
and stuff.
So who is actually going to be even in a position to participate in the poll, right, for either of them? Who are they internet users? That could be in itself a huge thing. Even if they are internet users, is there maybe an association between the particular paper or the particular website and the users, right? So does everybody look at the IMDb, or is it just people in certain countries? Does everybody really read the age, or are there differences in such preferences between age and non-age readers? And then it goes further, right? Among the people that have internet access and read this article, which ones are likely to vote? Well, the ones that care about this, either very strongly by saying, yes, they very strongly want this, or they very strongly do not want this, right? For shows or products, people that are really strong fans of a show, those are the ones that are likely to vote. The people that didn't really care about it, they're not going to care enough to vote on it. For the IMDb, you need to look at the actual user ratings. So so it's not just any vote that gets counted there, and they're not completely clear on which votes do. So it's just particular subsets of users. And then there's some algorithm in the background, and so on and so forth. So there's a huge problem here about self-selection going on, plus how and which votes are being counted, right? So self-selected samples. If it's just kind of a call-in or an internet poll or something like that, basically the sample is selecting itself by whether they see it or whether they actually want to respond. And that in itself is going to be very likely to bias results. So that type of thing is fun, but the ability to convey actual information is very, very limited. Yeah. That's clear, I think. And just a brief footnote, and this is not going to be news to any of you, but I think it's still important to say this. So this is not always about votes and polls, right? So one area where this is hugely prevalent is obviously also going to be comment sections, right, on articles or on virtually everything else that is out there. There are now long lists of comments. Who is likely to comment? Well, again, people who feel strongly about the issue in one way or another. And there's actually some scientific research showing that those comment sections, if you read them, are going to hugely influence what you yourself think about the actual article. Even if you don't agree with the comment, even if you don't think it's necessarily a qualified one, it's still going to influence your opinion. So there's actually now a debate happening, and you can read up on that if you want, as to whether these comment sections in general have failed. And the other area, of course, is going to be kind of product reviews, product ratings. You've all heard about fake user ratings, and there are lots of, so for instance on WikiHow, actually lots of strategies of dealing with that, which are then again specific to different websites, right? So that's another thing to consider. So that would be another example of a strong self-selection bias. Other forms of biased samples. So even if we have a random sample, and this is back to our Ontario study that we looked at earlier, here they've been selected, the students. They've not been just asked to participate in a study about alcohol use in Ontario, but we have a fairly low response rate. So that in itself can introduce something really similar to a selection bias, namely non-response bias. How likely is it that that subgroup of students or participants that actually participated in the study are representative of the larger group that were selected, who are then taken to be representative of the population? So response is going to be another thing to keep in the background. Yeah, what was the actual response rate? That's why that is so important. Another one, and this is again a huge thing for psychology studies, is something called availability bias. And that is very generally speaking the problem that what you're going to look at as a researcher, as somebody just in conversation, drawing an inference, is going to be hugely dependent on the types of examples that readily come to mind, on the types of evidence that are readily, easily available. And that is going to work on many different levels. So now I'm just going to give you, again, a few examples of how that goes. I'll skip over this one, but here's one. So this is a study investigating the availability bias where people were asked, well, participants were in two groups. One group had to come up with 12 examples in which they behaved assertively. The other had to come up with 6 examples in which they behaved assertively. And the question then was which group was going to rate themselves as more or less assertive. And the finding was that the people in the group that had to come up with 12 examples of assertive behavior actually rated themselves as less assertive than the other group. And that seems weird, right? Because they now have a longer list of examples where they had the actual target behavior. They actually have better evidence now for saying that they are in fact assertive, but that's the opposite of what they do. Why? Because it's more difficult to come up with 12 examples than with 6, right? So that is kind of a weird thing there in the background, and that's kind of a thing where you might easily be misled, right? It's hard to come up with examples, so that influences what you think. That's also a potentially manipulative technique, right, that might be used on people. So that's the availability bias. Here's one of my favorite papers from recent years, not really new anymore, but a huge issue in psychology, right? So this was in BBS, and you've all heard about studies looking at universal human traits, right? Psychology takes itself, in many cases, to be investigating things that are true of all humans generally, right? We don't think that psychology, if it's done very well, think about standard visual illusions or something like that, right? We don't tend to think that that is going to be culturally dependent. Well, what types of participants usually participate in psychology studies? Well, those that are available. Which ones are available? Well, predominantly students in Western countries. So the weirdest people in the world. What are weird people? Those are Western educated, industrialized, rich, and democratic societies. Yeah. And it's a subgroup of those people, namely people that go to universities that are your age. If it's an fMRI or PET study, it's going to be all males because you can't do that with women in case they're pregnant and so on and so forth. So there are a lot of things there in the background, and those are also predominantly likely to be not just any students, but psychology students. So can you really generalize from weird, often male, often young psychology students to just anybody in the world? Probably not, and this paper has like a long list of ways in which that might not work. So here's availability bias at work very generally in psychology. Fun thing to look at, bit disturbing, but just surprising as well. Last point, biased measurement. And again, there's going to be some stuff that I skip over, and some of this might be familiar. So it's not just the question, say you have a large representative sample, there's not a problem of the availability bias or self-selection bias or anything like that. Now, which measurement instruments are you using? And again, in psychology, for example, this is often going to have to do with the wording of questions, right? It's not just going to be an issue of calibrating a measurement instrument, a thermometer or something like that, but actually of wording good questions. Well, here again are two examples. People are much more likely to say that too much money is being spent on welfare than they're likely to say that too much money is being spent on poverty. So that's a simple, almost superficial adjustment that's going to completely tip results in a different direction. If you give more information, you're suddenly also going to give all other things being equal, you're suddenly also going to get different answers, right? Just by changing the wording of questions. Format of the question. So here's one that I found slightly creepy, and there's the website if you want to look in more detail. If you ask people to agree with a statement, right, the best way to ensure peace is through military strength. Many more people will agree with this than if you give them a forced choice between two options, right? So here's a question, do you agree, or how strongly do you agree? Will give you very different results from saying, is it either this or that? Now, which one is the true one? That does not follow from this at all, right? That's just saying asking different questions suddenly gets completely different results. So which one do you believe? Mostly an open question. Last example of that sort for today, order effects. So the thing to focus on here are these two numbers, right? So this is question about favoring civil unions or gay marriage. If you ask first just kind of about civil unions, legal agreements, you get approval of 37%. If you ask first about gay marriage and then ask about civil unions, legal agreements, that goes up to 45%. So it's by comparison that people are making their decision and not just based on the question itself. So often you can work against that by actually counterbalancing the order of questions, but that's kind of another issue there in the background. And this is something, so that's just one example, that even experts on certain issues are going to fall into this trap, right? So what order do you ask things in is going to strongly influence the results. Last thing, let's say all of that has been taken care of. Let's also say that you have people that think they are honestly, sincerely answering a question. They're not consciously lying. You might still get something like 98% of people saying that they're not racist. If you're a cynic or even just a realist, that doesn't sound right. Implicit bias might be a problem there in the background as well. So even if people think they're being honest, they might not be. And if you have a day or more to spend, there's a lot of empirical work on kind of implicit bias tests that you can run through and see how well you do on those, which can be fun in a way. So that concludes our content for today. Here are a number of questions summed up that you can ask of inductive arguments. Yeah, and then I'll see you in tutorials. Thanks.